let's get started. The first question that I have up here is just a review of the observation, hypothesis, experiment, or conclusion. So for these answers, A, B, and C, you can just abbreviate O, H, E, or C. So you can throw your answers up for A, B, and C. If there's a question, go right ahead. And I want to see some more answers for part A. Okay. We got a few answers. Yeah, you can put it all together in one. Let's start going over these, unless there's a question. All right. So for A, we have blind taste testers rate the flavor and texture of tomatoes grown in a greenhouse and tomatoes grown outdoors in a patch of soil. And I think I saw almost everybody writing experiment for that. That's right. So we're talking about a method here. We have some people, they're doing something, and we're talking about comparing tomatoes grown in one place versus another. That's an experiment. For B, tomatoes grown in soil taste better than those grown in a greenhouse. That is an observation. So I love tomatoes. And my neighbor, so when we first moved to North Carolina, she was growing tomatoes in her garden and she had a ton of them and she gave them to us when we first moved. And they were some of the best tomatoes I had had in a long time because the store tomatoes are kind of trash. The hothouse tomatoes and stuff like that, they're grown in a greenhouse. They don't taste the same. They don't hit the same. So that is my own personal bias. Yes, very trash. Very trash. I wish I had a green thumb. I do not. Mine is whatever the opposite of green is, that's what I have. Plants see me and they're like, oh man. But I love, love, love real good tomatoes. That's just an aside. That's so random, y'all. I'm sorry. Okay. Part C. 87% of tasters consistently rated tomatoes grown outdoors as tasting the best. That's the conclusion. We're talking about some results here. So it's clear that something has been done, and after that, you look at the data and you see what does it mean. So the 87% of tasters preferring something, that is a result. So if you see a kind of a result, that gives you a clue that it's a conclusion. I know last time there was a little bit of, confusion with is it an experiment or is it a conclusion. So hopefully that cleared it up for you. Now, number 2, write the following measurement in scientific notation. What do we get for that? Yeah, so we have to have a number that is at least 1 and less than 10. So that means we're going to move our decimal point between the 4 and the 1. And then we're going to count how many places. 1, 2, 3, 4, 5, 6, 7. Now we need to figure out if we're going to have a positive or negative exponent. Our number is much, much smaller than 1, so that exponent needs to be negative. So get on, y'all. Alrighty. Are there any questions about Chapter 1 stuff before we move on? I know that we want to go over significant figures and figuring out how many. We're going to do that. That's part of Chapter 2. But if there's any Chapter 1 stuff, this is the time. Otherwise, you can save it for the end of class, or I'm going to be having office hours on Wednesday virtually from 12:30 to 2:30. So that's tomorrow, 12:30 to 2:30. I'll bring that up again at the end of class, but just throwing it out there. If you don't feel comfortable bringing up your questions about chapter 1 stuff or something else related to the course, you can bring it to office hours and we can talk about it there. So now we're starting chapter 2. We're going to go over measurements, exact numbers, and then we're going to throw in the sig figs here as well, okay? So a measurement is something that you need an instrument for. You need an instrument to measure. So I'm deciding about whether or not I want it to be on Zoom or if I want it to be on Collaborate. I will send out a link tomorrow to let you know where to go. The problem with Collaborate is that I have a few separate courses, so you can't access the course room for CHEM 103 class if you're in CHEM 104 unless I share the link. So I'll work out the details of that and let you know, but it'll be early enough to where it's not going to be 2:15 like, oh shoot, let me send out a link. So I'll let you know. It'll be on Zoom or Collaborate Ultra through Blackboard. Okay. So measurement, you need an instrument. So a ruler, a scale, or a balance, something like that to take a measurement. Exact numbers, that's something you can count. You can count your fingers, you can count your toes, you can count the number of coins, you can count the number of penguins, okay? You can just count it, see it by observation. That's an exact number. We'll talk a little bit more about some other definitions of exact numbers, but for right now, that's what we're going to keep it. Which one of these, measurements or exact numbers, do we associate significant figures with? Which one do we actually need to report significant figures for? Measurements or exact numbers? Exactly. Measurements. We care very much about sig figs. I will usually abbreviate that SF because I'm lazy and that's a lot to write. So now what I want you to do is go through and for these 4 different numbers, tell me if it's a measurement or an exact number. And if it's a measurement, the number of significant figures. So I'll give you a minute to do those. And you can literally just make a chart in your notebook. And then we'll go through one by one and you'll tell me measurement or exact number and then the number of sig figs. So I'll give you 2 minutes to copy this down in your notebook and to do it, and then we'll go over it. Let's get started with this first one. 80.5 centimeters squared. Measurement or exact number. You can just put M or E. It's a measurement. The biggest clue to whether or not it's a measurement or an exact number is looking at the units. So we see centimeters squared. Anytime you see something that has to do with a metric system or SI, you're dealing with some kind of a measurement. In this case, centimeters squared, we're looking at some type of an area. So you have to make measurements of length and width in order to calculate an area. Since it's a measurement, that means we can count significant figures. How many sig figs are in this number? 3. Yep. So as we go through these examples, I'll address the types of zeros that we see. So in this case, we see a zero that is between numbers. So when it's between a bunch of digits, that zero is counted as significant. What about the second one? 12 drops. Measurement or exact number? It's an exact number. It's something that you count. So if you have a little dropper, I don't know if people color Easter eggs anymore. I might be old. I'm not that old, clearly. But when you color Easter eggs or you do anything with food coloring, you have a little dropper. So you can count how many drops, and you don't want to do too many or else it's going to come out looking terrible. That's an exact number. You count it. So there are no sig figs associated with an exact number. What about this third one? 560 deciliters. Measurement or exact number? It's a measurement. You'll see deciliters usually when it comes to talking about blood volume and lab report results. So usually deciliters is something that's involved with those types of things. So there's no sig figs for exact numbers. It's technically they have like an infinite number of significant figures because you know without a shadow of a doubt that there are 12 drops or there are 2 coins. There's no wiggle room for, oh, well, if you're using a ruler, I may estimate something as 7.35 centimeters. You may estimate it as 7.33. There's some uncertainty associated with it. But if I ask you, if I put a plate of cookies in front of you and say, how many cookies are there? You can count, there's 5 cookies. Everyone's going to agree. So that's why with exact numbers, we don't worry about significant figures because they have an infinite amount of significant figures. We can put a decimal point with 500 zeros behind that 12 for the 12 drops, and we would know with confidence that that's what it is. So that's why we don't talk about it. You're welcome. So how many sig figs are in this 560 deciliters? I agree. There are 2. Now let's talk about the 0 at the end. Notice how there's no decimal point. We're going to talk about that. There's no decimal, and we have this 0 at the end. This is a placeholder. If I told you I was going to give you $560 and instead put $56 in your hand, would you be mad? I'll need you to tell me. The answer is yes. Absolutely yes. And you don't want to hear, well, my check did. No. That 0 is a placeholder. If you don't have it there, then you have a completely different number. So there's 2 significant figures that are counted, and the only reason that 0 is there is that we know the difference between 560 and 56. So if you don't see a decimal and a number ends in a 0 or a lot of zeros, let's say it was 56,000, there's still only 2 sig figs here. Everything else is just telling you it's 56,000 versus 56. That placeholder 0 is usually the trickiest 0 that you have to contend with. But does that make sense about why we don't count placeholder zeros and how to tell the difference. If not, we can go over it. Yeah? Okay. So now let's cover the last one, 94.360 milligrams. Measurement or exact number? Yeah, this one's a measurement. Dead giveaway, milligrams. How many sig figs do we have? We are of two minds here. So some say 4, some say 5. The 5s have it. Here's why. This decimal point tells you that everything in this number is measured. So when there's a decimal point and you see a 0 at the end, it is significant. So you count it. So the decimal versus no decimal will tell you whether you need to count zeros or not count zeros as significant. Is that clear? We'll keep sig figs are going to come up again and again. So I'll keep pointing out the different zeros and I'll ask you how many sig figs there are. So by the end of this live lecture, you should have a pretty good handle on when a zero is significant and when it isn't. Let's move on. Sometimes when you're doing calculations, you're going to have to round. If you're doing a word problem, you've got various different measurements, and they each have a different number of sig figs. There's rules for multiplying and dividing versus adding and subtracting, which we're going to get to next. You need to know how to round and give the correct number of sig figs. So what I want you to do is for A and B, we're going to use this number 3.1457 grams and round to 3 significant figures, then round that same number to 2 significant figures. And we'll go over the answer. So I'll give you 2 minutes to do the problem, and then we'll go over it. Now, see, some of y'all are just on it. I don't even have to give you that time. I'll give you a little bit of time, though, at least 30 seconds, because some people may have been stretching and they missed it. I'm a mom. I know things. That's how I knew somebody was stretching. I just felt it in my spirit. Okay. So it looks like those of you who have participated so far are getting it right. That makes me happy. So for those who don't want to share, or maybe you're a little bit lost and you don't want to say something, we'll go over it for you because I care. 3 significant figures means that this 4, which I'm underlining, is going to be the last retained digit. The number that is it's not going to get chopped, okay? To round it, we're going to look at the 5 next door. 5 or more means that we're going to bump that 4 up. So for 3 sig figs, we're going to have 3.15 grams. And don't forget your units. The reason we're doing significant figures is because we don't have an exact number, it's a measurement. And each measurement needs a unit. No naked numbers. That's what, no naked babies, no naked numbers. That's just my belief. So always have a unit with your number. For part 2, we're using the same number, but instead of having the 4 as the last retained digit, we have the 1 because now we need 2 significant figures. So there's my cutoff line. I'm looking at this 4. It's 4 or less. So that means everything is just going to get the chopping block after the 1. So I think it was pretty clear. Everybody got it that put in their answer. So good on y'all. Clap, clap. So we covered measurements and exact numbers, the difference between those, counting significant figures, and we're still kind of working on that with the zeros. Now we just went over rounding. Okay, so when you have a big number from your calculator, you need to report 2 sig figs or 3 sig figs, not 12. You need to round. Now let's review the part that you do when you're solving the problem. So you're doing addition, subtraction. Oh, there's no extra S there. I thought I caught everything too. I caught it myself. I could have just been quiet and nobody would have said anything. All right, so we have to review addition and subtraction, and then we'll also do multiplication and division. So we'll do one example of each, and if you guys get both of those, then we'll move on. If not, then we can do some more. With addition and subtraction, how many of you just want to try it? Yeah, I was going to say, we can just try it and see, because hopefully you watched the video. So report your answer with the correct number of sig figs, because that's the trick here. We're not just adding, calculator can do that. But then we have to look at the measurements and figure out how many sig figs. So let's review that real quick. For addition and subtraction, what matters is the number of places. So you report your answer with the same number of decimal places as the measurement with the fewest decimal places. So just as a review, because we talked about the decimal places last time, this first measurement has the hundredths place. Second measurement only has the tenth place. Exactly. So I see some of us are getting it. So let's do the math real quick. I like to draw a dotted line if I'm doing it by hand. And that lets me know where my cutoff is. So this digit here is going to be our last retained digit because we can only report our answer up to the 10th place. So we're looking at this 6 to decide whether we round up or drop everything. So your calculator will tell you the 177.76. With sig figs, you should have 177.8 centimeters. Because your calculator will lie. It will not tell you sig figs. It will not tell you units. So this is the complete answer. Do we want to do another one, or are we good on that? Do we just need a little bit of a refresher? Yeah. Let's do another one. Excellent. Let's do another one. And addition and subtraction are the same. It's the same rules. So for me, addition for some reason is easier. So give that one a shot, and then we'll go over it. So your calculator is going to tell you, it's not going to have the zero at the end actually, but if you're doing this by hand, you might be tempted. You draw that dotted line. You don't need 4 decimal places. The top number only has 3 places. You only have 3 decimal places that you need to report because you only have to the thousandth place. Yeah. The bottom one has 4. So that's what your answer should be. Didn't have to do any real thinking. Your calculator in this case would have told you the answer that was right without the units. But let's say that we did have a 0 here, okay? Then we would have to change our answer. So actually, let me put that 0 in a different color. I don't want it to be confusing. Let's say that we added a 0 to that top one. Then that means that our calculator wouldn't have the 0. You would have to add a 0 to have the correct number of sig figs. Because in that case, you would need 4. Is that distinction clear? Because that is one of the topics about adding zeros, kind of. Yeah. So let's say that both of these numbers had 4 decimal places. That means for our answer, we would be reporting 4 digits. Your calculator will only tell you 3 digits after the decimal point. But because each of these measurements has 4 decimal places, our answer with sig figs would have to have a 0 added so that we have a total of 4 decimal places. Them zeros are tricky. They'll get you. Are we good to move on to multiplication and division? Great. So let's talk about the rules for multiplication and division, and then I'll let you loose on the problems. Here, what we care about is the number of sig figs in each measurement. So you're going to report your answer with the same number of sig figs as the measurement with the fewest sig figs. Last time we cared about decimal places. Yes, Olga, this is recorded. So you'll get to see the beginning. We did a do now and we did a couple of other problems before this. But it'll all be up on Blackboard. I'll post it before the end of the day. No problem. So remember, for multiplication and division, you're reporting your answer with the same number of sig figs as the measurement from the problem with the fewest sig figs. So for this first one, where you're multiplying 23 feet by 502 feet, you have 2 sig figs and 3 sig figs. So your answer should have 2 sig figs. Now, aside from that, I'm going to let you loose and report your answers with the correct number of sig figs. We'll also talk a bit about units as well, because when you multiply or divide, you're also multiplying and dividing those units. The first one is multiplication, so it's 23 times 502. So it should be a bigger number. Yeah, your calculator is going to say this. So remember, we need to take into account sig figs, not just what the calculator says. So for this first one, the calculator is going to tell you 11,546. Yeah, we're going to go over that. So how many sig figs are in this number from your calculator, 11,546? There's 5 sig figs there. We don't have 5 sig figs anywhere in our problem. We've got 2 and we've got 3. So how do we report it as 2? This 1 is going to be the last retained digit. We're looking at the 5 for whether or not we need to round up or just cut everything off, right? It's 5 or more, so we're going to round up. But 12 versus 11,546, two very, very different numbers. So when you're looking at that and you're rounding, just think about it. If somebody said, I'm going to give you $11,546 and they put 12 singles in your hand, would you be ready to slap them? Yes. Those are two different numbers. That means we need to add placeholder zeros because we need to make that number actually 12,000, not just 12. The other way to do this would be to report it in scientific notation. So how would you write 12,000 in scientific notation? We got one answer. Let's wait for a couple more. Writing 12,000 in scientific notation. Ah, don't forget that that coefficient needs to be at least 1 but less than 12 or less than 10. So you can't do 12 times 10 to the third. Not less than 10. Okay. So those are the two ways that you can report the number, as 12,000 and just add the placeholder zeros, or you can write this top number in scientific notation and then round it. Okay? We still haven't addressed units. We have naked numbers here. We got to get them dressed. We're multiplying the two numbers, but we're also multiplying feet times feet. If I did 8 times 8, that's equal to 8 squared. Same thing with the units. Feet times feet will give you feet squared. So that's the complete answer. If you have a question, let me know. If it makes sense, say you're good or give me a thumbs up. Sure, the units part or the whole thing? Sure. So we multiplied two numbers, 23 times 502. We got a big answer. Those numbers also have units, feet and feet. So if you think about area, let's say that you had a plot of land somewhere and someone came out and surveyed the land. That's what they do to make sure that when you pay taxes, you pay enough property taxes. They want all their money. So they're going to go out and measure, know all the property lines. They're going to measure your property. So this would be like a rectangle, right? When you have an area, you're multiplying one unit by another. And the units for area would be something squared, feet squared, centimeters squared. The reason is you're multiplying feet times feet, or centimeters times centimeters. Just like when you multiply 8 times 8 or 2 times 2, yeah, we know 8 times 8 is 64, but the other way to represent that is 8 squared. So if you multiply feet times feet, you're going to get feet squared. So it's the same thing. Is that a little bit more clear? If not, we can talk about it again either after class or in office hours. Okay, good. Now let's move on to the second one. So we had some answers. Some said 15, some said 20. Well, your calculator is going to tell you 15. We need to take into account sig figs. There's 2 sig figs in 75 centimeters cubed. There's only 1 sig fig in the 5 centimeters cubed. So that means we need 1 sig fig in our answer. We look to the 1, you have to round it up to a 2, but 15 and 2 are different. You have to add a placeholder 0. So that we actually have 20 and not just 2. So that's with sig figs. Does that part make sense? Because we still haven't done units. So if we need to go over it again, let me know. You can just say help, or you can say you're good and we can talk about the units. So scientific notation, you would write 2 times 10 to the 1. And that way you would have one significant figure. Okay. Other questions about that? Because this is how we're covering the adding the placeholder zeros. I know that's something that's a little bit tricky. Yeah, we're getting to that. I just want to make sure that everybody's good with the sig figs. So we can move on to the units. In this case, we're dividing centimeters cubed by centimeters. Now, what you don't normally see is if you see the centimeters there with no exponent, you're implying that it's a 1, okay? With exponents, the rule is when you're dividing them, you subtract. So that's going to be equal to centimeters squared because you're subtracting the 1 from the 3. So that's just the rule of dividing exponents. You may not see a lot of this in your homework and stuff, but I just want to make sure that you understand if you do have to do unit analysis, which we're going to kind of be doing when we're doing the conversion factors and stuff like that, that you understand where these things are coming from, where the units are coming from, and how we're manipulating them. So does that make sense? For division, if we have units that are in the same flavor, now let's say that I had centimeters cubed times seconds. Those are not the same. Or no, we're doing division, so I meant to say divided by. We had centimeters cubed divided by seconds. You can't simplify that anymore. Centimeters, we're talking about a length. Seconds, we're talking about time. There's no way to simplify that. So you would leave it alone. Let me know if that makes sense or if we need to talk about it a little bit more. If you're good, or help. Yes. So if what we did instead was 75 centimeters cubed divided by 5 seconds, it would be, the answer with sig figs would be 20 centimeters cubed per second. So this is a different problem. Well, we're talking about centimeters and centimeters versus two different unit types. If you're dividing and you have two different units, then you don't do any canceling. If you're dividing and you do have same units, then you do the thing with the exponents. You're welcome. I like the questions because I will be thinking we're all good to go, and everybody like question mark over their head. So please, please, please ask the questions as they come up because it helps me to make things clearer for the next class that I teach. I don't want to be trash for y'all. So help improve things. So are we good with multiplication and division? So we covered that. We covered units, and we talked about adding placeholder zeros. So those were the three things that we covered just on this one slide alone. Give me a thumbs up or I'm good or something like that, and then we'll move on. Cool. So we're going to carry forward the sig figs and all of those things. But first we got to do a little bit more building. Now we're going to talk about the prefixes that go along with the metric and SI systems and writing equalities. So in the lecture, I talked about that chart that has, all the different prefixes, what the numbers are, examples. You're going to want that right now. So pull that up. If you have access to the textbook, pull it up. If you printed it out, put it in your notebook, whip it out because you're going to need it for this. Okay. So we're switching gears a little bit. We're doing all the foundational stuff to build up to doing the conversions. I'm going to go through letter A, and then I'll let you guys do B and C. So letter A, we've got to fill in the correct prefix. 1,000 meters is equal to 1 blank meter. So we're looking for some kind of a prefix. This prefix is increasing the value of the meter. So we're looking for something that's going to make the meter bigger than what it really is. On the chart, you're going to look for the number 1,000, which is the same thing as 1 times 10 to the third. When you do that, you should find kilo, and its abbreviation is a K. So 1 kilometer is equal to 1,000 meters. Hopefully everybody has your chart by now. You can probably just look it up on the internet if we be honest. Try B and C and tell me for B and C what the whole unit is here. So I want the whole thing. Use the chart, fill it in. And if there's ever a question that you're just like, don't get it, you can literally just write help or I'm stuck. We'll give people another minute. Go ahead and put your answers in the chat as you get them. That's okay. So for this first one, for B, nope, we're not doing anything else. We're just filling in the blank. to know which prefix it is. That's it. We're not converting anything. So if you had 1 times 10 to the minus 3 grams, how could you write that with the prefix? You'd search for 1 times 10 to the minus 3, which is the same thing as 0.001, and you would see milligram. So the milli is one of the ones that decreases the value of the unit. So it's going to be less than 1. And the last one, C, is 0.01. That's the same thing as 1 times 10 to the minus 2. And that corresponds to 1 centimeter. Centi is another one that decreases the value of your base unit. So that meter, we're saying now we've got less than a meter. We've got a centimeter. So is that clear for everybody? You're not going to have to memorize the chart per se. If you need an equality for a problem, so usually you will need to know the relationship. So like centi, milli, kilo, you should know those. If it's something extravagant, something well outside of the normal ones, then you will likely get the equality, or you'll get some information about it. It's helpful to be familiar with the prefixes, but you don't have to memorize all of them. You're welcome. So let's move on. Now we're going to be writing equalities and conversion factors. So the first part is write an equality, and then from that equality, you're going to write 2 conversion factors. So let's quickly go over the equalities. We just saw what that looks like on the other page. We're just writing one number and then writing it again in slightly different units, right? The conversion factors, those look like fractions. So you're taking your equality and you're writing it as a fraction. Then you're flipping it over, and then you have 2 conversion factors. So for part A, we're relating meters and centimeters. If I have 1 meter, how many centimeters do I have? That's really what the question is asking. And you can look at the chart and see, okay, centi means that I have 0.01 meters if I have 1 centimeter. If I want to have 1 meter, a whole meter, then I need to have 100 centimeters. Does that leap make sense, or do I need to explain it? Makes sense. So that's how you need to use the chart, okay? That's the equality. Now, if you feel lost on this, do not sit there and be silent, because chapter 2 will come for you in your sleep, okay? An exam is lurking in the distance, and it's not too far away. Once we cover chapter 3, you're going to have all that you need for exam 1. So please, 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 if something doesn't make sense, even if it seems like it should, ask. If it all made sense to you, you wouldn't be in the class. So don't let anything hold you back from getting the help you need. Now, we have our equalities. Now we need to write conversion factors, and those are the things that look like fractions. So you're literally going to write a fraction like that. Then you flip it over, and those are your conversion factors. So for each equality, you can write two conversion factors. Part B is a little bit different. We're talking about 18% gold. So it's not using the charts, but we did talk about percentages as conversion factors and how to write equalities. So I want you to give that a try. Still need an equality too. But yeah, those are two conversion factors. It's all right. Maybe that's just how you feel on the inside. Your computer knows how you feel. I want everybody to give this a shot. Try to write out an equality and a conversion factor. If you can't, you can just say I'm stuck. That's still participation, but it lets me know where you are. Yes. Yeah, those are the conversion factors. You still need an equality. So the one with the equal sign. Yeah. Yes. So we'll write this one out. Okay. So we know that some piece of jewelry contains 18% gold. We know what percentages mean because we've been dealing with them forever. It means that you have 18 out of 100, right? That's what 18% means. But 18 out of 100, what? In this case, we're talking about gold. So if we have 18 grams of gold, then that means we have 100 grams of the whole thing, which is the jewelry. That's one conversion factor. So it's easy to start by writing out a conversion factor. To get the second conversion factor, you flip it. So those are the conversion factors. But what about an equality? An equality has an equal sign. We don't have anything like that up here. I mean, ignore this part over here, okay? So when you're writing an equality and you see 18% of a substance, you can just say grams and grams off rip, unless it tells you in the problem that you're dealing with some kind of liquid or, you dissolved sugar in water or something like that. Then you would have grams over milliliters or something like that. But unless it specifies in the problem, you can just assume grams. So is that good for everybody? Assume grams unless you're told otherwise when you're taking one of these percentages and making conversion factors. But now we need to write the equality. Just like in part A, where we took our equality and just removed the equal sign and put the slash for a conversion factor, you can literally remove this line here, that's the fraction, and make it an equal sign. So you can say 100 grams of jewelry is equal to 18 grams of gold. And that's your equality. It might throw you off because you don't see anything that has a 1 in it. It's not 1 of something is equal to X. We're talking about a percentage. We've got 18 grams of gold and 100 grams of jewelry. So I do recommend for the percentages, start by writing your conversion factors. And then you just take one of them, replace the line you use for that fraction, and make it an equal sign. That's your equality. Does that make sense? We're going to do some problem solving with the percentages and things like that. So this is just to kind of shake the cobwebs off and get some questions answered. And then when we get to solving the problems, we're going to go through all of these steps again. So if it's not 100% good for you after this slide, that's okay. We're building. So hopefully it's a little bit better between when you first started and now. And then when we do more problems, it'll get better. And then you work on the homework, it'll get better still. So it's a building process. Don't be concerned if you're not 100%. I get it. I'm ready to take the test right now. Okay. So let's try this last one. 1 gallon of gas is $3.40. Start by writing your conversion factors and then take one of them and write the equality just like we did for part B. If we're having trouble with this one, let me know. All right. We have an equality. Yep. Y'all are getting it. So this one is a little bit easier because it's a sentence. 1 gallon of gas is $3.40. We can make that is into an equal sign. 1 gallon, $3.40. That's your equality. We're establishing a relationship. Then the conversion factors, you write it as a fraction. Then you flip it over. So show of hands, how many of you feel more comfortable with writing equalities and conversion factors than you did before? A little better. So we will do some more of this. Don't worry. This is not the end. As long as we're building, as long as it's a little bit better, or at least not worse, then we're okay. So this is a good time to take a break. We'll take a 10-minute break. It's about to be 12:10, so we will come back at 12:20 and get going again. Alrighty, everybody. It's time to get back to it. We have about another hour of class to go. We're leading up to kind of the hardest part of chapter 2. We're doing the equalities and conversions and leading up to solving problems, so actually doing the conversion. I know you guys may still be a little shaky on writing equalities and conversion factors, but we will get there. I promise. As I said, we're going to go over each of these topics in depth individually. We're going to start with percentages as conversion factors. So just like we did before, where we had the jewelry, we now have 18% body fat, okay? Let's say a person has 18% body fat. If we were going to write an equality for that, what would that equality be? Those are conversion factors. So the equality, remember that an equality has an equal sign. Conversion factors have fractions. Yeah. So it would be, if we have 18% body fat, then we automatically say, okay, let's say that we have 18 grams of fat. That's going to be equal to 100 grams of body or sample or person, okay? So what we did was we took that 18% and said that's equal to 18 over 100. That's what 18% is. Then we took each of those, we added grams to it, and then we put other units to say what it is. So 18 grams of what? Fat. If we're talking about body fat, then that means there's 18 grams of fat for every 100 grams of person or body, or whatever, however you want to qualify that. That's a conversion factor. So if you can do that, take the percentage and convert it to a conversion factor. From there, you can literally take and replace that line. If you replace it with an equal sign, then you get 18 grams of fat is equal to 100 grams of your sample. So that's how you can get to the equality from a conversion factor. Does that help? Because we haven't answered the question yet. We're just talking about writing an equality and writing conversion factors. Okay. So we already did half the work for the conversion factors. And I'll keep labeling these because you need to know the difference. We wrote our equality. I'm going to abbreviate conversion factors CF. We already wrote one of them. To get the other conversion factor, you just flip it over. So those are our two conversion factors. Now we need to take that information and apply it to the problem. If the person has a total of 21.6 pounds of fat, how much does the person weigh? So we were doing grams, and that's fine, but now we're told pounds. So we can change that grams to pounds. It really doesn't matter, okay? It's the same idea. So here's the question. How much does person weigh? We have our conversion factors, and we also know that there's 21 pounds of fat involved, okay? The way you would set up this problem is you take that 21 pounds of fat, and then you have to use one of your conversion factors. We're trying to get rid of pounds of fat. Right now, we have pounds of fat in the numerator. To get rid of it, we need to cancel it out by having pounds of fat in the denominator too. Which means that we need to have a conversion factor that has pounds of fat in the bottom. So I'll just kind of write over this. Pounds, grams, whatever you want to use here. Okay. The problem is talking about pounds, so we'll talk about pounds. Which conversion factor, A or B, has pounds of fat in the denominator? B. So that means we're going to use this conversion factor. And we haven't used any numbers yet. We're just talking about the units. If I have pounds of fat in the numerator and pounds of fat in the denominator, I can cancel them out. So the units I'm going to be left with is pounds of person or pounds of body. So that checks out. Now you fill in the numbers from your conversion factor. So we said we're going to use B. So we have 100 pounds over 18 pounds. That's our conversion factor. To do the problem, put it into your calculator. You're going to do 21 times 100 and then divided by 18. So give that a shot in your calculator. You can just tell me what your calculator gets. When you do 21 times 100 divided by 18, what does your calculator say? Yeah, it gives you a number with a repeating decimal. We'll put a few extra. So that's what your calculator says. But we are scientists, so we have to use significant figures. Remember how I said earlier that we're going to talk a little bit more about some other exact numbers? If we look at the equality that we have for this problem, we have the 18 grams of fat is equal to 100 grams of body, or pounds, whatever you want to use. This 18 is measured. So that means it's going to contribute to us figuring out how many significant figures we need to report. This 100 is exact. A percentage is always out of 100. So you can put a decimal point, an infinite number of zeros. We know without a shadow of a doubt that that 100 is a 100. So it's exact. We don't care about sig figs for that number. Two sig figs from the 18%. We're told a number that has 3 sig figs. So we can only report 2 significant figures. We care about sig figs for the question, but we don't care about the 100. That's only because it's exact. A percent is always out of 100. And that 100 is the same always and forever. Infinite number of decimal places that you can put. We are 100% sure it's 100. But the 18 we care about, because that's measured. Is that more clear, or do we need to go over that again? Okay. I'm going to just say it one more time, because if there's one person saying it's not clear, there's at least one more person who is still lost. So we have our equality. 18 pounds of fat is equal to 100 pounds of body. Okay. That 18 pounds, that is a measured number. Someone had to use an instrument like a caliper or something and do BMI and all that stuff, figure out how many pounds that equals. That's measured. Measured numbers always have significant figures. But the 100, that is an exact number, because a percentage is always out of 100. So we don't need to think about significant figures for it. We know without a shadow of a doubt that whatever percentage is it's out of 100. So we're only going to care about the sig figs for the 18 out of this. Uh-oh. Raise your hand if you can hear me. Okay. So you may, well, I can't. Tell her to, she may need to enter and exit again because sometimes that just happens. Thank you. Appreciate it. I love it when y'all are responsive. I'm telling you, it makes my life so much better. So, measured numbers, we care about sig figs. The only measured number is the 18 pounds or the 18 grams, not the 100. Now, here's the other question. How do we report this number with only two significant figures? Right, we got to use placeholder zeros. Yeah, if ever, the audio goes out for one person, tell them, hey, leave and come back in. But also the video is going to be posted. It's not exactly the same as, being present in it and participating, but it's something. Yeah, if you have a question, go ahead. Did you say when or where? So in each folder for each chapter, there's a folder that says live lecture, and that's where the PDF of all this stuff I'm writing is going to be, and the link to the live lecture on YouTube. So I teach another course literally right after this one, so it's not going to be posted until the evening, but it will be posted before the end of the day. So you can wake up tomorrow and look at it. You're welcome. So to report this number with two significant figures, we've got to use those placeholder zeros. So we would report this number as 120 pounds. We're rounding that 1 and looking at the 6 saying, okay, it's 5 or more, so we're going to bump the 1 up to a 2, and then this 0 is a placeholder. I think I have another example for percentages as conversion factors. So let's work on that one together and see where questions are. Unless you have a specific question about this problem, I think it would be the best use of our time to try another problem and see how it goes. We good with that? Okay. So the other example that was in the lecture was talking about salmon. I like salmon, and especially being pregnant, ain't a bad fish to eat, okay? So it contains 1.9% omega-3 fatty acids. And the question is, how many grams of omega-3 fatty acids are in a 113-gram salmon fillet? First things first, before we even start talking about how to solve the problem, what I want you to do is write an equality for the 1.9% omega-3 fatty acids. We want the equality and the conversion factors. So you can start with the conversion factors and then go backwards, or you can just write it out because you get it. Whichever way, take a minute and end up giving me the conversion factors and the equality. So you don't have to change you can say 1.9. So you got the numbers almost right. We're almost there. Let's wait for a few more answers to come in. Let's try to add some units to that. The problem is talking about grams. So 1.9 watt is equal to 100 watt. I'm sure the video for the live lecture sounds crazy because it's literally me talking to myself. I don't record anything that anyone else says. You can't see the chat because y'all ain't about to get me on no lawsuit. But hopefully the one-sided banter will still help. So let's write it out. For the equality, I'm feeling a color change. Let's do purple. We've got 1.9% omega-3 fatty acids. I'm going to start, since it seems like starting from the percentage makes the most sense to most of you, that we're going to write out 1.9 out of 100. That's what it means, right? Now we need to add some more units. We're talking about grams here because that's what we see. So let's add grams and grams. The 1.9% is talking about the omega-3 fatty acids. The 100 grams, well, we're talking about salmon contains 1.9% omega-3s. So in every 100 grams of salmon, we're going to have 1.9 grams of that fat. This is a conversion factor. Remember, I abbreviate that CF. You can replace this line with an equal sign, and you get 1.9 grams of the fatty acid is equal to 100 grams of salmon. Yes. We will be. So next week we're going to cover what we don't finish, which will likely be 2.6 and 2.7. So this is the last part of 2.5, and then the other slides and problems are on 2.6 and 2.7. So the homework that's due on Sunday is only 2.1 through 2.5 because I figured that's all we'd get through. The Sunday after that, it's the rest of the homework and the Chapter 2 quiz because you can't split that up. So I'm trying to help y'all out, okay? Good question. So that's our equality. Are you with me for how we got to the equality? Because that process where you take the percentage and write it out as a conversion factor, and then we replace that line with an equal sign, that won't fail you because you know what a percentage is. So let me know if you're with me up to this point. Great. Now we need to write our second conversion factor because currently we've only got one. We need to flip that sucker upside down. We put the salmon on top and the fatty acids on the bottom. That's our second conversion factor. Now we're ready to set up the problem. So the question is asking how many grams of omega-3 fatty acids are in 113 grams of salmon. Let's set up this problem. Actually, I'm going to pause for a minute because I want you to try it. So try to figure out how many grams of fatty acids there are. We're not concerned with sig figs yet. I just want to see if you can get to the calculator answer first. Take a minute and try that. If you're looking at this and you're like, help, please put that in the chat. Don't be ashamed because I would like to know. So we've got some answers. Let's see. Let's see who gets it. We're starting with 113 grams of salmon, which, by the way, is approximately a 4-ounce piece. So that's like a serving of salmon. If you get like the frozen fillets or something like that, that come vacuum sealed in a pouch, it's about 4 ounces. I told you I'm serious about salmon. I know it well. We need to cancel out the grams of salmon, and we have grams of salmon in the numerator. So where do we need to put grams of salmon in our conversion factor so that we can cancel it out? Does it need to be in the numerator or the top or the denominator? Where are we putting those grams of salmon? Yes, the bottom. We have it in the numerator already, so we need to put grams of salmon in the denominator. Which one of the conversion factors are we going with, A or B, since we need grams of salmon in the bottom? We're going to go with A. When you put that into your calculator, you're going to do 113 times 1.9 and then divide that by 100. So your calculator should tell you 2.147. So several of you got that calculator answer, and using the right conversion factor is where a couple of you got tripped up. But you understood that you had to set something up like that and use a conversion factor. So that's the step in the right direction. How many significant figures do we need to report our answer with? We need 2. So with sig figs, our answer is going to be 2.1 grams of fatty acid. How do we feel about that? Meh? Good? Better? Okay. Also acceptable? Okay. So the keys to the kingdom, good. It is tricky, but practice makes perfect. The first key is figuring out what that equality is and writing out your conversion factors. The second key is figuring out which conversion factor to use. And you always want the conversion factor that's going to cancel out the units you want to get rid of and only leave the ones you want. To cancel out, you need the same units in the numerator and in the denominator. So when I write out these questions and I'm writing out the calculation, I'm writing this in this specific way for a reason. The numerator lines up. So when you're doing this and you're writing out your method, make sure that you're very clear about what needs to be multiplied by what and what needs to be divided by what, and keep your units clear. We can do more practice of this. So there's percentages as conversion factors, and then there's also just doing metric conversions and things of that nature. So what I propose is that we continue on, because we're going to be doing the same thing with writing equalities, writing out the conversion factors, and then choosing the conversion factor that's going to get us from point A to point B. So let's keep trucking. We'll do some more problems. Next week, we will start with doing a few more Chapter 2 questions to reinforce what we're doing now. And then we'll cover Chapter 3, which is no math and considerably easier. Everybody good with that plan? Great. So we'll have new problems for next week. We're just going to keep on trying them. So this time, we're doing a metric conversion. We're off of percentages. They're fun. We're going to leave those behind. So if you have that chart that's still handy with the metric prefixes, that will be helpful. But I can tell you that milli that's what milli means, okay? How many milliliters are in 1.82 liters of water? Report your answer in scientific notation. So we're going to walk through this one step by step together. The first thing that you have to do is write an equality. You can't convert if you don't know what you're converting from or what you're converting to. So what units do we already have just from the problem? How many liters are in 1.82 liters of water? All right, we've got milliliters and liters. So we're starting with liters, and we're trying to get to how many milliliters there are. That's a summary of the question. Now we need to write an equality. Let's say that I have 1 liter. How many milliliters is that? Take a second, look at the chart. So when you look at the chart, it's going to tell you 0.001 liters, right? That's what 1 milliliter is. If we need a full liter, then we need to have 1,000 milliliters. So that's our equality. The second step, you're going to write your conversion factors. This is the easy part. You're just writing 2 fractions. Is everybody with me so far? We wrote an equality, and then we wrote some conversion factors. Now we need to figure out the actual problem, okay? We're asked to figure out how many milliliters are in 1.82 liters of water. We're going to set up our calculation. And I'm going to do that on the right-hand side here. We're starting with 1.82 liters of water, and that's from the problem. Now it's decision time. We have 2 conversion factors. Which one are we going to use if we want to end up with milliliters as our answer? Yes. We're going to use B. And if we just go through and look at the units, liters in the top, liters in the bottom, so they cancel. We're left with milliliters. You do that multiplication, you're just moving the decimal point to the right 3 times. 1,820 milliliters. Do we need to do anything else? How many sig figs are in our answer? 1,820. There's only 3 sig figs. This last 0, remember, there's no decimal place. If you don't see a decimal, then you don't count that 0 as significant. So we've got 3 sig figs there. We started with 3 sig figs in the problem, so we're done. It's the same exact steps as the other problems we were doing with percentages. But instead of writing a conversion factor and everything from a percentage, We're figuring out the equality based on what we see in the word problem. Yeah, it's okay. Look, it's a long time. It's 1 o'clock. We started this 2 hours ago. So I completely understand. It's a long time. 2.5 hours. That's a long time to do anything except sleep. So is the longer you hang with me, the more impressed I am. So how do we feel about this problem? If I gave you something like this, do you feel like you might be able to tackle it? Okay. Then let's try one. So you're performing an experiment that requires you to measure 56 milligrams of sodium bicarbonate. FYI, that's baking soda. Your balance reports mass in grams. So how many grams of sodium bicarbonate do you need? Report your answer in scientific notation. So I'll start you off. Our question is we have to measure out 56 milligrams of sodium bicarb. How do we write that in grams? We need to know what the scale is supposed to say for us to know that we've got 56 milligrams. So remember your steps. You're going to write an equality where you say, okay, I've got 1 milligram. How many grams is that? Then you're going to write your conversion factors. Then you're going to set up your calculation. And that's where you choose which conversion factor you're going to use to go from milligrams to grams. I will give you 3 minutes just to get started. You may not finish in that amount of time. If you do, you can put an answer. But I want you to get started. And if you get stuck somewhere, I want to know where you get stuck, because that will help me diagnose what we need to dive into more next time. So take 3 minutes. That will be 1:06. We've got a couple of answers. We're coming up on 106. So just by a show of hands, how many of you were able to get to the point of writing conversion factors? You can keep putting your answer in the chat, but if you didn't get to an answer, how many got to conversion factors? If you got to an answer, I see that. So we got to the point of writing conversion factors. Okay. So a few of you got to conversion factors. How many were stuck at the equality part? You said, oh, you want an equality? Okay. So we're going to set up the equality first. Yeah, I see. So we're talking about taking milligrams and converting to grams. When you're writing your equality, you want to reflect that. So we're talking about if I had 1 milligram, how many grams would I have? Because that's what the chart can tell you. The chart can't tell you straight up 56 milligrams, but it can tell you 1 milligram. So you look up milli, and you look up its relationship to grams. You'll see milli along with 0.01, 0.001, excuse me, and 1 times 10 to the minus 3. Milli is one of the prefixes that decreases the value of your base unit. So grams is going to be less than 1 gram. 1 milligram is less than 1 gram. So you can fill it in however you want. You can put in the 0.001, or you can put in 1 times 10 to the minus 3. So that's our equality. Let me write or here. This is not a fraction. Either one, they're the same thing. Does that help with figuring out the equality? Because I know if there was one person who didn't get there, then there's other people who are watching a movie and they certainly didn't get it. Okay? All right. Now we need to write our conversion factors. Yes, ma'am. Yeah, that's the same thing. Same thing. As long as the relationship is right. So I always think about it in terms of putting 1 is equal to something else. But the same. When you do the math, it will work out. Yeah, good question. Now we need to write our conversion factors. So I'm going to go with what I wrote, but you know how to write conversion factors. That's the easier part. Now we have to set up the calculation. We're starting with 56 milligrams, which we got from the problem. And we need to choose a conversion factor. Which one will get us from milligrams to grams, A or B? B, because it's got milligrams in the denominator, and that will cancel out. But just to make sure, you always want to go through, cancel out your units. to make sure you're left with what you're interested in. Now, the reason I chose to write it this way and to write the equality in scientific notation is because you're most of the way there with reporting your answer. That's not proper scientific notation, okay? But it's pretty close. We just need to move the decimal point over one time to the left. Because remember, you're supposed to report your answer in scientific notation. So if that were an exam question or a quiz question, and you put 0.056 grams as your answer, it'd still be wrong because it's not scientific notation. So don't forget that little detail. A few of you got the answer, okay, and that's great. Some of you got as far as setting up the conversion factors, which is still really good too. This is a tough topic. What I want you to do, and you can do this just as practice, is you can go the other way. So instead of 56 milligrams, let's say that you have 56 grams, and you need to figure out how many milligrams that is. You don't have to write the conversion factors and all that stuff out again because we already have it. But try setting up the problem with the correct conversion factor to go from grams to milligrams, and let me know what you get. Sure, I can rephrase the question. So it's literally, you have 56 grams of sodium bicarbonate. How many milligrams do you have? Yes. So you should get 56,000, which is a big number. Now I'll quickly show you what you should write for that. So if you were using my equality and my conversion factors, that's how you would set it up. Yeah. So if you were doing scientific notation, 5.6 times 10 to the fourth milligrams. So I'm going to say that we end here. I'm going to skip over the next. So there are I have several other problems that we're going to get to next week. So we have more conversions, and then we also talked about density and density as a conversion factor. So we're going to save those topics for next time. You've got some practice with the conversions to where you can start attempting the 2.6 questions for the homework if you so choose. But let me get to the slide that has the reminders for when things are due. So, Chapter 2 check-in, which is over all of Chapter 2, okay, and the Mastering Chemistry homework, section 2.1 to 2.5, that's due on Sunday the 6th. So you will have to do a conversion or two for the Chapter 2 check-in, but that's because I want to see where you're at so I can help you before you have to do it for the quiz and the homework for Mastering Chemistry. The rest of the Chapter 2 homework, which is 2.6 and 2.7, along with the quiz, are going to be due on September 13th. That's also the same day that your Chapter 3 homework and quiz are going to be due for Chapter 3. I promise Chapter 3 is not bad. It doesn't really have math. It's just, we're talking about matter and energy, okay? I promise you it will not be bad at all. That's the same week that you're going to have Exam 1. Exam 1 is going to cover the first 3 chapters. It's going to be available on Blackboard the 16th through the 18th. Is there a question? Yes. Yeah. So because it's in the syllabus and it's a distance learning course, we have to require everyone to use Respondus Lockdown Browser and Monitor. So in the spring semester of last year, because everyone got sent home, we had to do some workarounds and try to figure stuff out for people. You can, however, contact the chair of your department or the dean of your department because they may have resources for you. If you're on campus, you may be able to borrow a laptop that has the capabilities that you need. So you need the camera and the microphone to function. There is, oh, and that reminds me, thank you. There's a practice test that's already posted. It's not a real test. It's just asking what's your major, what year are you, that kind of thing. And it also gives some options for when office hours could be and what works best for your schedule. So that's the practice test for you to set up Respondus Lockdown Browser and Monitor and try it out. I'll get a little more information about you. You'll get 3 test points that will be the easiest test points that you ever earned in your life. So try that out. If you already have it, yeah, borrow from the library. That's a good option if you're on campus. If you're home doing this, if you have a friend or a cousin or somebody else that has a computer with a camera and a microphone that works, then you can do that too. But I just wanted to give you the heads up about Exam 1. Chapter 2 is the hardest chapter out of the set. So y'all can figure that out. I don't know all the, yeah, I figured it would already be downloaded because it's university software. So we have a license to use it. Yes, what's your question? It'll be posted this evening, but I can't tell you exactly what time because I teach a class right after this. So if you look for it tomorrow, it'll be there. You're welcome. Are there any more questions about when things are due, about the flow of the class? I know it's fast. And doing chemistry this fast is tough, especially if you're just coming off of like the high school schedule where things are a lot more slow paced. But I am having office hours. Yes. Question? Yes. Yeah, it's right here. So it's broken up. 2.1 to 2.5, that homework is due this coming Sunday, along with your Chapter 2 check-in, which is pretty short. The 2.1 to 2.5 does not include doing the conversions that we were doing. It includes the percentages, but not the metric conversions and stuff like that. Okay? So that's what you got to be concerned with for this Sunday. The other thing I was going to say is that this Wednesday, tomorrow, I'm going to have office hours from 12:30 to 2:30. It's either going to be on Zoom or Collaborate Ultra. I will put a link in an announcement tomorrow once I figure out which one I want to use. But I'll put a link and say, hey, office hours, 12:30 to 2:30, slide through. You can come and ask questions, send me questions through, what can you use for help on? Let me answer that in just a second. You can email me questions or send me questions through the course messages in Blackboard. You can also, while you're doing Mastering Chemistry, send a question to your instructor, and that will send me the question that you're having a problem with, and then you can say, hey, Dr. Hefner, I sent you a question. Can we go over that one? For the chapter check-in, so you can stop by office hours tomorrow. You can send me a message. But really, going through and using the examples that we did in class today will help you in setting up and doing the problems for the chapter check-in. So we've done all the problem types for the most part. That's on the chapter check-in. And I just want to see where you are. The chapter check-ins don't have as much weight as the Mastering Chemistry homework and quizzes do. So the check-ins are really participation. It's only 10%. So as long as you do it consistently, your attendance will be good, and you'll have a decent participation score. So this Wednesday, which is tomorrow, 12:30 to 2:30, there will be virtual office hours, obviously, and it'll either be via Zoom or it will be Collaborate Ultra. Either way, I'll send you a link with all the details in an announcement tomorrow. Other questions for me? So please do try to do that Respondus Lockdown browser practice test. Yes. What is your question? Right. So if you get at least an 85, then you don't get the adaptive follow up. Um, if you get less than 85, then you can try to make up some of those points. There's also extra credit. So so that's due by the end of the semester, but I've posted some dynamic study modules that you can do in between time that will help you study so you can get extra credit that way. So everybody's got opportunities to earn some extra points. Cool? No, they're on Mastering Chemistry as well. You should see it in the available assignments. But I can't tell you specifically off the top of my head exactly where you'll see it, but I made at least two of them available that are relevant to what we've been doing and what we did last week. But I can double check that and I'll just post something about it in the announcements for you. Great. So if there's no other questions for me, we're done.